Hey everybody, Pete A. Turner, executive producer and host of your Break It Down show. You are going to love today's episode. We have Knicole Colon from, get this, NASA. Yes, we're now friends with NASA here at the Break It Down show. Let me just say this one more time. We are now friends with NASA on the Break It Down show. And we have Knicole Colon, who's coming on, and she's an astrophysicist. She does all kinds of crazy things. But the most important thing is she's got two projects she's working on. She's worked on similar projects in the past, back when they were active, things like Hubble and that kind of thing. She is on the Tess Exoplanet Observatory project, and then the upcoming Webb project. Both of these observational platforms are redefining how we examine and what we're able to examine when we look out to the stars. This stuff is exciting. So whatever Hubble could do, think of that as being like one thin silo. Incredible within that silo. But Tess is like, I'm just going to do the whole thing and do a 360 dome of everything and give the scientists lifetimes worth of information. What we can now see and examine has exponentially cubically, whatever's the biggest way, like multidimensionally exploded. And now Webb is coming, and it's going to change it all again and make it, we're going to learn so much about the cosmos in the next 20 years. It's going to blow our minds, and it's just so neat to have Knicole talking about this. And you can tell, listen, when someone loves their job, they sound like Knicole. Her joy from a couple days ago when we recorded to now is making me smile. You'll hear her giggle and have a great time. And she's doing what she loves, and she's doing great things while she's doing what she loves. And so you're going to love what Knicole talks about. We talk about space a lot here on the show. We had Robert Jacobson on before. We've had any number of astrophysicists and cosmologists. Our dearly departed friend Andrew Friedman had come on a number of times. So you guys know I love space and talking about, how about Megan the Martian? Megan, another friend of mine who is trying to become someone who helps us build habitable things on Mars. These are great shows. So I hope you guys all appreciate that. Knicole is a fantastic guest. We'll be hearing more from NASA in general. I want to try to get them on a number of times throughout the year because there's always some great new thing. Like we learned about Venus may have life up in the clouds. What? This happened since Knicole and I talked. There's always these new leaps, these new bits of knowledge, and I think it's important for us all to see this, especially when we realize, hey, we got a Space Force trying to help us keep things under control for us out in space. Here's one of the reasons why. We've got a lot of things going on. There's a lot of growth, a lot of expansion. All right, a couple things real quick. It really, really, really helps when you share the show. I can't tell you enough. YouTube is really kind of clamping down now, and they're trying to change things again, and we're always fighting that battle. There are so many observational and fun things you can do on the web, to include the Break It Down show. So when you are able to share one of the things, like the Break It Down show, it really helps. It helps to stand out because there's a lot of competition, a lot of people putting great content out there. And just when you get a chance, if you give us a share, once a month, once a week, whatever it's going to be. One more thing I'm going to say to you about Save the Brave, savethebrave.org. There are just a few raffle tickets left, and we will be raffling this rifle off. It's hard to say. And I think they're $100 of tickets, and I think there's less than 20 of them left. So this thing's going to go soon. So if you've been meaning to do it, here's your chance. Don't forget, it's for charity. So even if you don't win, you still win because you help out Save the Brave. All right, go to Save the Brave, savethebrave.org. Put in a donation. Help us out. We will put that money to work. If you look on Instagram, you will see the guys were all out fishing the other day, and you can see the smiles, and that's what that money goes to do, is get some smiles on some faces and hopefully save some lives. All right, one final thing to say. Here comes Knicole Colon. You're going to love her.
Lions Rock Productions.
This is Jay Moore.
This is Greg Proops.
This is Jordan Harbinger.
This is Dexter from The Offspring.
This is Nathan
This is
East.
Sebastian Younger.
This is Rick Morales.
This is Stuart Copeland.
This is Mick Gillette.
This is Andy Summers.
Hey, this is Skunk Baxter.
This is Gabby Reese.
This is Rob Bell.
Hey, this is John Leon Guerrero.
Hey, and this is Pete A. Turner.
Hey, this is Scott Tickers, and you're watching The Break It Down Show.
This is Knicole Colon, and you're watching The Break It Down Show.
Well, it took a minute, huh, Nicole? Technology is incredible. You can put a telescope millions of miles out into space and look into light years away, but sometimes getting a microphone to work is the hardest thing in the world to do,
100% true.
Yeah.
And you work in a technology world. Just for everybody, Nicole works for NASA and on the TESS program. That's why we're here talking about that. And it's just all this space stuff is just fascinating to me because there's the exploration side at the national level, like you do. There's the commercial side with Starlink throwing up satellites and just it's insane how this is all exploding. For the 12-year-old girl in New Jersey who fell in love with this kind of world. What do you want to tell that girl? I mean, this is remarkable.
Yeah. So for reference, he's talking about me. I'm from New Jersey. I was 12 when I knew I wanted to study the stars. And looking back, I never knew that I'd be doing today what I am actually doing, working for NASA, at NASA, helping find new planets around other stars that are light years away. It sounds like science fiction, but it's my reality.
Yeah. And it's amazing to think that we can put $1 billion observation platform like Kepler into space and think, it'll work for a few years, and it works well over 10. But then it just goes away. Like it's just what's it gonna fall into the sun eventually, whatever?
Actually,
yeah.
some spacecraft do, but Kepler, it's still just floating out there all alone, sadly, by itself. But it's off, and eventually, decades from now, it'll kind of fly by the Earth. It's not going to come close enough, to us for us to do anything with it, but we'll be able to wave at it and say hello.
So, and just for the audience's sake, and I'm also there's a lot of stuff that you've talked about, the overall program. So I want to kind of use those other episodes that people have done with you, which are all remarkable, but really get into Tess and what's next and that kind of thing, because it's a lot of those questions have already been explained, but let's really briefly explain what Tess is and what your role is within the program.
Sure. So Tess is an acronym. So it stands for the Transiting Exoplanet Survey Satellite. So really what it's doing, it's looking at stars that are light years away, and it's literally just measuring the brightness of a star, and it's looking at it over time for 27 days at a time, typically. And it's just staring at that, measuring brightness, and it's looking for little dips in the brightness. And when you see a dip on a periodic time scale, you can say, hey, maybe that's actually a planet blocking the light from the star from our point of view. And that's what we're seeing with Tess. That's what Kepler did as well. And both have been phenomenally successful so far.
There's a lot of stuff in the sky. So how do you know that, whatever, Glessy 25 Delta, that there wasn't just, a rock floating across, the thing? How do you differentiate between a planet and space junk?
Yeah, that's a good question, because again, we have a lot of space junk in our solar system, right? Between satellites and various space rocks that just didn't form into planets, even comets, asteroids, all that, right? So for us, the easiest way is to look for a repeating event. So something that, we see a dip on this day at this time, and then let's say 10 days later, we see the dip the same size, same length, same properties basically, and then we just catch it repeating. So that's why we need Kepler and Tess, those types of facilities, to look and just stare at the sky for days and days and weeks on end.
And then a planet like Uranus or Neptune, they have really long years. You can't reliably just look at that. How do you deal with that?
Yeah, it's hard. I want to find analogs to our solar system, and it's really hard because Saturn has an orbit of 30 years. It takes 30 years to go once around the sun. That's a really long time. We haven't had anything like Kepler test up in space for 30 years to look for systems like this, so we do what we can. And because of that, right now we've been kind of biased, finding things that have orbits similar to Earth or shorter, like orbiting closer to their stars. So we're working on the longer period ones, but it'll take time, literally.
Yeah, it's interesting when you think about Uranus. The year was, I don't know, 80 years or something like that, and so you may not throughout your entire lifetime ever have the chance to have it transit right? Because it's a fairly singular point of view from our perspective that you're examining. Is that right?
Yeah, you have to be looking at, the right stars, obviously, that has a Uranus-like planet. Um, and then it has to be aligned along our line of sight. So,
Right.
we have to see it cross in front of the star. Otherwise, it could be the whole system's tilted, so we're never going to see it cross this way.
Right.
So there's probabilities in there, and
Yeah.
and that's why really literally the longer you look, the more time you look, then the more objects you'll find, like Uranus or others.
There's a lot of stars. There's a lot of solar systems out there. How many can Tess track at one time? I mean, I know it looks like the full,
Mhm.
sphere, but that's a lot of stuff to keep track of.
It is. I mean, tests at any given time, well, there's a couple answers really, because it's looking at, these huge swaths of sky, where it's looking at millions of stars, but it depends how bright the stars are, whether tests can actually dig out a signal from those stars.
Mhm.
So that's, part of it. But then Tess is also looking at tens of thousands of stars more rapidly than it is in other times. So sometimes it'll take an image every 30 minutes, but then for a select sample of stars, it looks every 20 minutes.
Huh.
Or not 20 minutes, I'm sorry, 2 minutes, actually, even faster. So I was thinking in my head, 20 seconds is actually another new observation mode that Tess is
Huh.
doing now. So for even a smaller sample of stars, it's getting an image every 20 seconds.
Wow.
So you're just getting an incredible amount of data essentially to look for these planets.
Yeah, and how do you have like an AI function where it helps you sort it out? I mean, you're not just looking at ones and zeros, something's helping you examine these millions of stars to look at, right?
Yeah. So the official science team is looking at everything. Well, not everything. They're looking at a lot by eye, actually, because it is a very manual process sometimes. But
Huh.
there's all this code and programming behind the scenes, that basically takes the data, looking at the brightness versus time, and it is able to sift through and look for periodic signals. So the computer
Mhm.
can do that, but then the computer does that, the pipeline we have, and then it sends, the promising signals off to the science team, and the science team then looks by eye and says, okay, this one, is probably just something, not interesting, not a planet, or
Yeah.
maybe interesting but not a planet, not that it's not interesting.
There's
um
so much
mhm.
data. I mean, do you
Yeah.
when there's things that you guys aren't, and I'll use the word bias in terms of the scientific aspect of it. If you're looking for solar systems like ours and you find one that's a binary star and you got planets in opposite things, are you even paying attention to that? Or are you like, the research is this question here that we're trying to answer?
It's for that exact question that you just asked. That's why we literally have a community around the world working on tests. So, I referred to the science team, but that's the official science team that runs the mission, who's based out of MIT up in Boston. That is the team looking and finding bona fide planet candidates for us to follow up with other
Right.
telescopes. Um, but yeah, they're only looking at, this kind of specific sample of stars and all that. So things with, you know, crazier signals with some crazy eclipsing binary and, all kinds of whopping variability, or, the stars doing crazy things. A lot of that gets left to the general astronomical community. So,
Mhm.
anyone can look at the data. It's all public, and there's a lot of people looking, and several of these have been found already. Planets orbiting two stars.
Yeah, that's crazy. And then when
Mhm.
planets orbit two stars, do they go around both stars or do they kind of do a figure eight? What do they do?
Mhm. Yeah,
It's probably all of them, but
probably all of them. But so far, the ones we've detected, either with Kepler or Tess, you have the two stars orbiting pretty close to each other, and then there's another star orbiting further, or another planet, excuse me, orbiting further out. So it's orbiting around both stars. There might be, well, it's a very chaotic environment, right? If there's a star and then a planet around the star, and then another star like really nearby.
yeah.
so So in a lot of ways, we don't think that environment is stable for a planet to form and, live in that system without being what we call ejected
Right.
and just, flung out and far away. So as far as we've discovered so far, there's two stars orbiting really close and then a planet that will be orbiting around both stars. And, it's not unlike Tatooine, as we like to say, in
Yeah.
Star Wars.
Any 3-star systems at all?
Oh, that's a great question. There are definitely planets where there are three stars in the system. Off the top of my head, I can't recall if the planet orbits around all three,
Uh-huh.
but there's at least a scenario where there are three stars that are essentially part of the same system. So if you were on that planet,
Yeah.
you would see three suns in the sky, you would see that clearly, clear as day, how we have our one bright sun and then a bunch of stars at night, right?
Right. And then how far out are you guys looking? Like how many light years?
Oh, we've been looking, I mean, the closest star is about 40 light years away. So we've been looking from there and then out to thousands of light years away. So,
Right.
but it's all still within our galaxy. It's going to take a lot of effort to find planets in other galaxies.
Okay. I didn't know that. So
Yeah.
it's just strictly within our galaxy here. And
Mhm.
then when you look at, or when Tess looks at a tube of things,
Mhm.
how often are planets aligned where like it's hard to tell because there's, one is for at least a time eclipsing another solar system?
Mhm. Oh, yeah, there are certainly cases of overlapping systems, like you're saying, where you could have two different stars not associated whatsoever, right? And they
Right.
each have planets. Um, I mean, that's really requires additional observations then, because Tess can give us the initial signal and say, "Hey, okay, there's planets here. We know there's planets here,
Right.
but which star is it around? Yeah, what's going on exactly?" That then requires other telescopes, which we have a squadron of, of ground-based telescopes that are used for this type of effort to say what exactly are we looking at, and
Right.
it's very powerful.
When you guys find a new planet that you're interested in, does it become like oh, that's Nicole's pet planet, she loves whatever the name of the place is, and then do you have to like fight for like the resources for your little planet versus someone else's planet and time and energy and all that stuff?
you know um yeah, it's not quite like a fight club, no. But no, I mean, in reality, a lot of what Tess does is actually really cooperative. So,
Hmm.
you say there's this list of planet candidates put out by the science team, and everyone has the opportunity to essentially claim one as their own, to follow it up and say, "Oh yeah, is this a real planet? Is it
Right.
an eclipsing binary star? Is this something else?" So luckily, it's quite cooperative, and I mean, at the same time, there's still only so many sources. There's a lot of telescopes on the ground that we can use for follow up, but it takes a lot of time to follow up.
Mhm.
There are more than 2,000 candidate planets from TESS already, for instance, and
Wow.
it takes a lot of time, telescope time, to follow those up.
Yeah, that's shocking. So, I
Mhm.
mean, in the 90s, we started realizing we could find exoplanets. How many have we found total now between Hubble and TESS and Kepler?
Mhm. Oh, there are over 4,000 now
Wow.
confirmed,
Wow.
and 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 well, yeah, and that's just confirmed. So then there's thousands more candidates out there waiting to be confirmed. So there's always some chance there'll be like some other type of astrophysical signal, or even the telescope that discovered it, like Kepler test, can have some kind of what we call instrumental noise or artifacts that can cause a false signal. But those are pretty small numbers. But so yeah, we think a lot of the candidates are actually real and valid. So I won't be surprised if we hit 5,000 confirmed soon.
Yeah. Are there more planets than we expected would be possible, or are we kind of in the cone of normalcy? How has it gone?
I before Kepler launched, which was back in 2009 already, uh, we knew of a lot of, or we were starting to find a lot of exoplanets, but they were really massive and they orbited really close to their stars. So they were nothing like what we have in our solar system. And we said, is this what's actually common? And what does that mean? Why is our solar system then so different? Right.
Right.
And then Kepler launched, and then it revealed, no, actually planets are common, and it's just that the big ones were easier to find first, of course. But then Kepler found a lot of small ones, and we said, okay, they really are common. And now we're confident in saying that if you look up at any given star, on average, it's going to have at least one planet, if not more.
Wow.
And
Yeah.
without a doubt, we're comfortable saying there are more planets than stars in our galaxy. So there's just so many.
I guess that begs the
Mhm.
question then, do you think there's intelligent life out there somewhere for us to find?
I do, actually. Absolutely. I mean, there's just by sheer numbers alone, there has to be some kind of intelligent life, even if it's only one other civilization. I
Yeah.
mean, I wouldn't be surprised at all if there was different kinds of life that necessarily, not something we would call intelligent. But on a lot of planets, even in extreme environments, there's bacteria that can thrive, right? And all
Right.
kinds of those types of organisms. So yeah, I think sheer numbers alone, what we've discovered so far tells us there are more planets than stars, and there are billions of stars. So there are billions of planets out there. So at least one's got to have life.
Yeah, yeah, I totally agree with you. And then
Mhm.
we had I guess a cosmologist on, and he was talking about the makeup of a given solar system
Mm.
or galaxy, and if there's just more gold there, or whatever the elemental things are, or elements we don't know about, and how that might change everything in terms of the balance, in what we're looking for, right?
Oh, absolutely. That's why, I would say I'm comfortable saying about our own galaxy, right? That
Right.
I think there's got to be some other life here, but other galaxies, exactly, they can be very different than ours because since this is our home, we can study it really well, and we can be comfortable with what you just said, the chemical composition, and the carbon and oxygen ratios and, things we're familiar with on Earth, right?
Right.
And see, okay, what is that like for our galaxy? We can figure that out. Other galaxies, I'm not an expert in other galaxies,
Yeah.
but it's obviously easier to study things that are closer to you in
Yeah.
general, so in
Yeah.
detail. So yeah, so I'm confident, saying with that, within our galaxy, Kepler has shown us planets are everywhere, basically, and so that means there's got to be some life out there.
John, who's my co-host, he
Mhm.
asked, "Are there any significant sized planets that travel in clusters?"
Oh, interesting. So there are, well, I'll say, I guess there's kind of two ways to answer that. So there are a number of stars that have multiple planets, right? Like our own solar system.
Right.
But there are a lot of these systems that are really scaled down, packed in. So there's 6 planets that orbit, really close to their star, compared to ours are all kind of spread out in our solar system around our star. So in that sense, they kind of travel together. There's a bunch of stars really close to a bunch of planets really close to a single star. Um, but then there are stars that form in clusters and live in clusters. And we've just really in recent years been finding planets that orbit those stars who are packed into clusters, but they're not, um, I guess they're not super dense.
Uh-huh.
So they're still really interesting because they are within these clusters that tells us, okay, planets can be stable around stars when there are other stars nearby. They don't get ejected, right?
Right.
So we do know of some of these systems, but we're still learning. and a lot of those are younger, also much younger than our sun.
Huh.
So it tells us too about planet formation and how how planets in general can form in young and dense clustered environments.
Yeah, interesting. And then a system like Alpha Centauri, I'm assuming that because it's close, that we can examine, what's going on there with greater detail, or am I totally wrong on that?
You're right. I mean, it's so the one thing about that system. So there is a planet that we know of around Proxima Centauri, and that is the closest. So that's part of that Alpha Centauri system, right? And it's only about 4 light years away. The thing is, well, because the star's so close, we've been able to study it and say, okay, we found evidence of a planet. But the difference there is that we found it not using the same technique as Tess and Kepler. It was found by looking at essentially the wobble in the star's
wobble.
orbit.
Right.
So the only downside there is that we can get a mass of the planet that way, but we don't see the planet cross in front of the star, which means we don't get its radius. So we don't know quite how big it is, and what the density of the planet is, essentially, because that can then tell us a little bit more about what its atmosphere could be like, and lead to a whole other avenue of research.
Yeah.
So because it was so close, we were able to detect the small planet, but we're still limited in what we can learn just because of the orientation of the system, literally.
And then when you talk about, the density of a planet, they have like these cotton candy planets that are enormous, but there's just nothing in them. How do you even tell that? I mean, it's so far away. It blows my mind. I know you're going to say math, but how do you know? Like, it's just so crazy.
I know, it's true. I mean, some of my favorites, like you said, are cotton candy, or there's styrofoam planets,
Yeah.
And I love that because it blows my mind. Like, how do they even stay together? How are they a cohesive planet that we can detect? But it is, it's a combination of what Tess does and Kepler did. Where we're able to get the size of the planet, and then using instruments on the ground, we're able to measure the wobble that the planet causes on the star. And it's basically an equation of gravity and and a relation between mass and radius to say, oh, okay, now we know this planet based on the mass from the wobble and the radius from the transit, we get the density. Oh, it's like, a density of diamond, or styrofoam, or cotton candy.
Hey, this is Pete A. Turner from Lions Rock Productions. We create podcasts around here, and if you, your brand, or your company want to figure out how to do a podcast, just talk to me. I'll give you the advice on the right gear, the best plan, and show you how to take a podcast that makes sense for you, that's sustainable, that's scalable, and fun. Hit me up at pete@breakitdownshow.com. Let me help. I want to hear about it.
Styrofoam or cotton candy. And so there's a little bit of math, but actually not too much, actually.
Right. It's remarkable. I mean, even just like our own planets here that are in the neighborhood, and how like it might rain diamonds. I think it's on Uranus maybe, or Neptune. Like it's insane. All these impossible Star Trek kind of worlds. Like, what do you mean it rains diamonds here? And there's methane mud and all this. It just boggles the mind that even just here in our own system, it's so diverse. And then what I wanted to get to the question is Jupiter has its job. It flings things out, it absorbs all this extra stuff, and it makes life a little less chaotic. But also, the moon makes the Earth really like we need each other. The moon doesn't need us. I mean, but we need the moon to make that happen. Is that going to be a thing that we have to find to have, planets that have these enormous moons compared to their size? I mean, is that a requirement, do you think?
That's a really great question, because as you just said, the moon, plays a role. We have tides, right? Because of the moon and the ocean, there's this interaction. And, we wonder, okay, how much does having a moon affect the presence of life on Earth? That's I think something that we're still figuring out, but we're doing what we can really to find
Yeah.
Jupiter-sized planets and down to Earth-sized planets, even smaller we found already. But we haven't quite found bona fide evidence of a moon yet around these planets. But we're hoping that, as the longer we look again, we'll be able to dig out some of these signatures. But any given moon is going to be smaller than the planet, which makes it harder to detect, of course. So
Yeah,
there's
and I was going to ask, like, how
yeah.
hard is it to find these moons? I mean, are they common for you guys yet? I mean, you'll at some point someone will figure it out, but how hard is it to
Yeah,
find a moon?
it's it's extremely hard. I mean, right now there's only really one good candidate moon that was discovered in Kepler data, and then it was later followed up with Hubble, actually. Um,
Huh.
and there was still tentative evidence. So where the astronomical community is comfortable calling it a candidate moon, but
Okay, good.
we're not quite there to call it like a
Uh-huh.
bona fide moon yet.
Right.
But we have, even coming up next year, the James Webb Space Telescope, which is going to offer even more precise quality data that could allow us to then detect or recover a candidate moon and help verify that it is real. But it always takes time, and we have to find the candidates first off, so it's definitely a hard process.
Yeah, yeah. When does the web, when does that launch?
Right now that's scheduled for fall 2021.
Uh-huh.
So the working launch date is actually Halloween, October 31st,
That's fine.
2021. Mm-hmm.
And then when does it get into its spot where it can start doing work?
Oh, it'll take about a month to get to its final orbit, but then it takes another 5 months actually to basically set everything up. It's got 4 different instruments. It has to unfold its mirrors because it launches folded up, and it
Right.
has to unfold like this huge sun shield to protect the telescope from um, heat from the sun.
Hmm.
So it takes some time to do all of those deployments and then set all the instruments up. But yeah, so we expect about 6 months after launch, then it'll be starting science. So early 2022 we'll be there.
Mary and John are asking some questions about,
Mhm.
just the ability to get
Mhm.
to, Alpha Centauri's planets, that kind of
Mhm.
thing. And would we even send someone? I mean, let's say that we could go fast enough to make a 4 light year jump, in somewhere near 4 years, and we could survive all that. And then, by the way, slow down and stop, bring enough fuel to do that, But let's say that we could do that. I mean, would we send someone? And is it even in our lifetimes physically possible to go 4 or 5 light years away? It seems close, but we also know it's really far.
Right. Yeah, right, because exactly the closest planet that we could try to visit is 4 light years. So if we were traveling at close to the speed of light, it would take about 4 years to get there. um but we kind of have to start small and work our way up. And that's what we're doing. There's this whole NASA initiative, the Artemis program. It's going from the moon to Mars. So we went to the moon 50 years ago,
Right.
um, for the last time. And we're basically building new shuttles, right, and new equipment, new facilities to get us back to the moon. But then, really, it's not about the moon. I mean, it is, but it's more
Yeah.
about having a gateway then to launch from the moon to other planets like Mars as our closest neighbor. Um, and then that's the current goal, right? So that's the goal we're hitting for 2024. So only 4 years from now, which is about the time it would take to get to Proxima Centauri if you could
Yeah.
go go super fast. But this is all a jumping off point, right? So to get the technology to say we can hop around our solar system, right? Once we're comfortable doing that, then we can push even further and go beyond. And so hopefully in my lifetime, that would be amazing to see some of that, but it's really hard to predict. But there could be new technology around the corner, right, waiting to be
Yeah.
discovered that
Yeah.
could enable some of this to expedite that process.
Well, and even just if you could send someone or even a probe of some kind and it was
Mhm.
4 light years away, it would just take a long time to communicate with that machine. I mean, with Mars, it's
Yeah.
hard, you know?
hmm It's true. And there's I mean, we have missions around Jupiter right now, and even the Voyager probe is way out at the edge of the solar system. That was launched many years ago before I was
Yeah.
born. you know, and and but that we've improved some processes. So like with Mars, we'll be getting there in a few months. The That Mars rover just launched
Right.
a couple weeks ago, right?
Yeah.
So, there's certainly technology has improved a lot in the past 50 years, even since, we've gone to the moon. Um, so I think time will tell.
Yeah. Yeah. And one of the things I'm always interested in is, I learned in science class that nature hates a vacuum, but it seems like vacuums are the common thing. It's,
Mhm.
these like the earth is not common in terms of that stuff, and we just
Mhm.
don't survive it well. It seems really hard to put a person reliably out into space, because things break. There's so many variables for 3 or 4 year trips. It seems like we have to almost do robots,
Mhm.
for anything beyond Mars.
Mhm. Yeah, we might have to, like you said, stick with robots for the time being, until we kind of get comfortable with the whole moon to Mars program. I
Yeah.
think
Yeah.
once, getting back to the moon is obviously saying, okay, we did it before, now we can do it again with our current technology, which has improved vastly. But let's do the next thing. Okay, let's go to another planet that's much further away for, that would require X years of a journey because, it's a matter of bringing astronauts there, but then also bringing them back. We don't
Right.
want to leave them there.
Yeah.
So, like
Yeah.
rovers, we leave on Mars, rovers stay there. So, and all the other missions we send out, to Jupiter and all that, and
Right.
Saturn, they stay there. So we got to bring them back.
Yeah, well, I mean, that's the idea, right? Like,
Mhm.
you're not much of an explorer if you go and you never come back. You're sort of just. Is there a planet besides Mars that we should send a human to here in the solar system? I mean, none of them are really in. You can't go to Mercury. You can't go to Venus. I mean, not if you want to stay alive, right?
Right. Yeah. Venus is really tough. Its
Yeah,
atmosphere is quite detrimental to
to say the least. Yeah,
yeah, to even robots. So,
right.
I think the best or the most interesting place perhaps would be one of the moons of Jupiter or Saturn because we're already planning to send robots or missions and rovers and things like that to for instance Titan, um, which that will include a helicopter that's going to fly on
Oh,
Titan. So,
nice.
it's really fascinating. It's called the mission's called Dragonfly.
Uh,
And so, that's kind of something similar enough to Mars and Earth where it's kind of like a rocky terrestrial planet with a thin atmosphere that's just really cold because it's so
yeah,
far away from the sun. Um, but yeah, I think that's going to be a natural other place for humans to step foot on within our solar system before expanding, if we can, to beyond.
do you have a favorite amongst the moons, like Callisto or Ganymede? Any ones that you think like that's where we got to go because there's going to be orcas there or something?
I think Europa is pretty cool. Europa's a good one.
Yeah.
Io is really interesting. It's got volcanoes. I mean,
Ooh.
just thinking about the types of environments and how they have some features that are so similar to Earth, but yet they're so far away, like it's hard to imagine. But then you see pictures of them and it's just fascinating to say, wow, that's it's not that it's just another, moon or just another planet. It's really interesting, but it's not really as exotic as you might think. Like it's not necessarily science fiction.
Yeah, yeah. John's got a great question. Is there a
Mhm.
cooler job in America than what you're doing right now?
That is a great question. I might be biased. I mean, working at NASA, finding planets around other stars,
Yeah.
it's pretty cool. Gotta say.
So I want to get in because the sexiness of the job is fun and learning about these planets. I mean, that's an incredible opportunity, but you still work for a giant governmental organization, and they're like, "Hey, we got to have a briefing room," and you're like, "Just get me out of here! I need to get behind the telescope or grab these, stacks of data." But what is it like day to day for you? Like, what's your day in the life of Knicole at work?
Yeah. Oh, a day in the life. Answering a lot of emails. I mean, it's yeah. A day in the life is probably not too different than certain jobs where I'm on meetings. Well, now a bunch of telecons,
Yeah,
all virtual.
yeah,
Been working at home since March myself, and that's the plan for a while. So there's meetings and emails and all that, but the topic, of course, is very different than what most people work on. I mean,
yeah.
for me, I work half on tests, which we've been talking about. That's half time. My job is to work on tests and help basically other astronomers use test data and make
Okay,
sure they know how to access the data, and make sure they know what the data looks like and
right.
what is the telescope doing right now. So it's kind of keeping the public and astronomers up to date on tests. And then my other half is actually working on the James Webb Space Telescope.
Oh,
So I also work on, so that's, I mentioned, is launching next year. And for that, I'm kind of the exoplanet point person for the mission. And I'm currently, helping again to make sure that the telescope, since it hasn't launched yet, is basically ready for exoplanet science. Anything we need to study the atmospheres of planets. That's a lot of what
yeah.
it's going to do. And so there's just a lot of meetings surrounding that, a lot of emails surrounding those topics, a lot of telecons, but I get to do a lot of cool things too, like, talk to you guys and
Yeah.
talk to, give other interviews or just talk about the missions. So it's a lot of fun.
I don't want to put you on Front Street and say anything that's that shouldn't be said, but how much because it's Zoom and you're not even in a conference room, how much eye rolling, how much texting, back channeling does that stuff still happen? I mean, you guys surely must be like an organization, where you're like, ugh, Johnny is gonna talk again. He's the worst. I mean, do you guys have that kind of vibe where like here you are doing this incredible work and you still have this mundane minutia stuff that just infuriates? Is that stuff present still?
Well, what I will say is that we're all human, right?
Yeah,
Working at NASA. So, I mean, we have human emotions. I mean, we always, like anybody at any job, we get frustrated at certain things, if things get changed last minute or don't go our way for whatever reason, or
right.
but then there's so many perks to it, of course, as well.
Of
So
course.
it's I think you do experience a range of human emotions
Yeah.
in meetings.
Yeah.
Put it that way.
I remember when Robot Chicken was doing its Star Wars stuff, and it's hilarious because when you do some kind of alternate fiction on the fiction, you can really explore
Mhm.
these things. And one of them is the Emperor is evil and he's yelling, but meanwhile, the Death Star is being assembled, so there's contractors everywhere, and he's trying to have a meeting, and they're like sawing, and he's like grinding. It's like all these realities of running an organization. Those things are
Mhm.
it's just hilarious when you think about it. Uh, when in terms of like something like the Webb project going up, how
Mhm.
many people does it take to do that? Because you've got project managers like crazy, you probably have an overall,
Mhm.
you've got your specific role, and then also within that, if like the newest thing comes out, like is the Web set? Can it be changed? Or you're like, oh, we need one more gyroscope because that'll make this
Mhm.
happen. Can you talk about some of that part of it?
Sure. Yeah. I mean, so to address the first part of your question, there are literally thousands of people working on
Mhm.
this telescope, and it's around the world effort between NASA and as well as the Canadian Space Agency and the European Space Agency. So there's major partners literally all over the world, and everyone has a different role.
Mhm.
Um, a lot of it is actually settled in terms of what is going to be on the spacecraft. All of that has been set for a while.
Okay.
And so the actual spacecraft right now is out in California, and it's all put together. It's all folded up. It's just doing final testing, actually, and undergoing final testing, simulating launch, and just checking out all the systems, right? And that everything looks okay to go,
Yeah.
essentially.
Yeah.
So the telescope is set. However, there are other factors that we can work on, which is there's 4 instruments on the telescope that all do different things. And so they all have a bunch of different modes of ways they can observe not just planets, but galaxies and
Mhm.
and even solar system objects and all kinds of stars. So there are things being done now to help add some new features, essentially,
Mm.
to what we can use the telescope, to how we can use the telescope. Uh, but the actual components of the telescope are set, finalized. That's not going to change.
Right.
um, and because we're a little over a year away from launch, and it's just undergoing final testing now, and then it actually has to ship on a boat, and it's getting shipped out to French Guiana is where it's launching from. Yeah, so it's got to make a journey quite a ways from California out there. Takes a couple months, I believe.
Yeah. Yeah. And I guess that's a
Mhm.
delicate trip too. Like you have to pick the right
Mhm.
time of year, and there's so many factors with that.
Yeah, absolutely. Have to
Mm.
be it safely, and make sure it's really secure, of course.
I'm a big fan of near Earth space and like the commercial industry that's going to
Mhm.
open up, and I like to just take like proxies from what we have here now
Mhm.
on Earth and think, will that be up there? Like I believe in the gravity wells between us and Mars that we'll have like flying J truck stops, for like
Mhm.
space shuttles,
Yeah.
because it can sit out there. You come out here, like we'll have some fuel, we'll have some tater tots on a grill, and then you can go off to the next point. But my friend Todd, he's asking about space junk, and I've been
Mm.
thinking about this. Like, will there be a got junk rocket that will go up and just start flinging things back towards Earth? Because it'll burn up, and because we have so much stuff already up, and then
Mhm.
Elon Musk is launching thousands of satellites, and there are so many other constellation
Mhm.
programs,
Right.
for different companies that are throwing things up. But yeah, what's the thought? I mean, at NASA, what do you guys want to see?
That's a yet another great question, because there's a lot of stuff up in space already, um, orbiting near Earth, and in some cases, like certain things we destroy on purpose, like the Cassini mission that went to Saturn. We flung that into Saturn to burn up. End of story. But a
Yeah,
lot of it, they're in stable orbits around the sun. We talked about Kepler earlier, right?
yeah,
That's orbiting around the sun. It's going to be there for years. It's going to fly by Earth again, but it's just there. We're just leaving it there because in some ways it's more expensive to bring it back and you know destroy it or put it in a museum or what have you.
right, right.
So there's a lot of space junk, and you mentioned a lot of things being launched still. Certainly a lot
Yeah,
of these satellites, and I don't know personally the any official plans, whether it's NASA or if it's um, other government contracts, right? Who are up in space. The military has stuff in space, so
yeah,
there's a lot of stuff in space that's not NASA, as well as there's other countries, the
yeah.
other space companies that launch things too. So I think we'll have to see. I mean, the International Space Station is up there, and even though there's a lot of space junk, it's pretty safe. It doesn't really it's not like it's getting bombarded with items.
Right. Yeah,
So it's kind of hard to say. Like the problem right now, I guess, as isn't that bad, enough that we need to do something right now. But I can imagine very soon we'll want a plan.
yeah,
So
yeah.
it's very possible people are working on a plan right now. Um, mhm.
One of the things that's also fascinating about space, as I've explored, the commercial side of it, is all these new jobs, like the space lawyers. Like, oh no, we
Yeah.
can't do that, or hey, we're going to sue you. I mean, this person exists. Constellation managers,
Mhm.
all these crazy jobs. Is there some organization that says, hey, we're going to build Tess here in the United States and Webb, and so France is like, well, we'd like to build the whoever, pick a French person, Pascal or somebody, and throw this up and fill a different slot. I mean, because you
Mhm.
only get to do so much stuff. Is there some organization that kind of manages that so the different space agencies work together?
There's so there is an International Astronomical Union, but they're more for different roles. So, for example, they come up with official naming schemes of solar system objects or exoplanets or what have you. So they have certain policies that they handle, um, but for the most part, at the major space agencies, which are NASA and the European Space Agency and a couple others, certainly. Australia just created one, I believe, in the past couple of years as well,
Mhm.
for instance. NASA's kind of been a front runner in terms of putting out a lot of space missions, certainly, like, and leading efforts like Hubble and James Webb. But the biggest ones, they have these partners on, like James Webb has partners from multiple countries.
Right.
Um, but otherwise, like the European Space Agency, let's say they do their thing, what they'll do is they'll announce, oh, these are the missions we're proposing or we're selecting. And so NASA will take that into consideration and say, oh, well, ESA's launching, let's just say an X-ray satellite. So we're not going to worry about that, because they have that covered or something. So they will consider, I don't know how much goes on behind the scenes, right?
Right.
In terms of planning, but they definitely take that into consideration when planning. What should NASA fund? What is ESA already funding? They'll look at that and say, let's not duplicate efforts exactly because we want to learn the most we can, and it's better to do something a little unique.
I remember in the mid 2000s when we had a problem with one of our Mars missions, and the European, folks kind of laughed at us, obviously in a good sports kind of way, and then they immediately dirt darted their Martian probe, into the side of a cliff on Mars. Are we still getting significantly better at I mean, most of the time these missions work, but still, like if you send up 100 shuttle missions, we know a certain number of them are going to fail catastrophically. But are we getting that number to be something in, like, in 1,000 rather than in 100 in terms of catastrophic mission failures?
uh I hope so.
Okay.
I mean, I don't have an official number to put on it, right?
Right.
But I will say, of course, we learn obviously from not just every mistake, but from every success.
Right.
And what modes work, what operations work, um, things like that. And then we have partners too, like, we launch spacecraft now, NASA missions on SpaceX shuttles, for instance,
Yeah.
right? Or
Yeah.
SpaceX rockets. So there's there's always a procedure and process they
Hmm.
follow, certainly. And we do the best we can, of course, to try to mitigate any past errors and not repeat them. But as we go on with new technologies and everything, a, some things aren't just going to be lather, rinse, repeat. They're always going to be
Right.
new things we're trying. So we're just doing the best we can, and hope everything goes smoothly. But at least there's always like safe modes and contingency plans.
Hmm.
So they
Yeah.
definitely
No, for
build
sure.
those in just in case.
It's also remarkable, given the thousands of people it takes to put Webb into space and everything else, and all of the different smart people working with. You guys don't seem to get, at least from my point of view, bound up by analysis paralysis. You guys seem to be action oriented. Like, we're going to get this thing up, and maybe we got to wait a few weeks because of a storm. But it's remarkable that you guys are able to do that.
Yeah, I think we're pretty adaptable, I'd say, and even if something launches and it's doesn't operate quite as perfectly, like maybe it has a perfect launch, right? And it gets up to space, and then you say, oh, maybe it's not quite working as expected because of this reason. Well, we can adapt and try to say, okay, well, now let's have some engineering, feats of strength and see what can we do on the ground to still optimize the mission and get the most we can out of it. And, it's kind of common, I guess, to have, like I said, these contingency plans, certainly.
Yes. A little bit of a silly question, but I think it's kind of fun. So when Tess finds something, it's not like the old days where someone's looking through a telescope and then they get to name it, because the names you guys are coming up with are crap. So like what I really want is like, hey, I found this star system with a bunch of stars, and I'm going to name them after the Golden Girls. So there's going to be a Rose Nyland, and there's going to be a Blanche Devereaux. The Blanche Devereaux is too close to the star because it's hot. They'll have a crappy planet, and that could be, Stanley Zbornik, the unfaithful husband. But are we going to get back to naming some of these things other than Glessy 21b Alpha Echo?
Yeah, and I mean, for better or worse, there is this, quote unquote official naming scheme, right?
Yes.
Where you have the mission name oftentimes, or whatever the mission decides, like they want to name something. Because, for instance, Tess, the planets are not called Tess 1b or Tess 2b. It's a lot of the planets that Tess discovers. They're round, bright stars with other names that are like from these catalogs, like you said, like, LTT 1445 or something.
Yes.
And it's like a historical catalog, and so they use that name, and that's what it's called. But in other cases, they're given names like they're called TOI something, like test object of interest. So it's like this kind of, it's a little different, but it's still letters and numbers, stringed together. So I mentioned the International Astronomical Union earlier, and they did have, I don't know if it was a competition or, some kind of program where they selected a few exoplanets that were known and had the public rename them. And for the life of me, I can't remember like an example of what won, but there are a small sample of exoplanets with kind of alternative public friendly names. But as astronomers, we don't really use those. So, I wouldn't even know it if you said, oh, this planet's, name is Osiris. And I'd be like, what's that?
Yeah.
I'd be like, you mean HD 209,
Right. Vega. What the hell's Vega? Yeah.
Yeah. I mean, if there was a planet around Vega, it'd certainly be Vega 1b, but at least Vega's a nice name.
Right.
Yeah.
When I took astronomy in college, I learned that you follow the arc to Arcturus and speed on to Spica. And do you guys have things like that to remind yourself where things are? Here's why I'm going to say this, because when I was also in college, I worked at Costco, and people that worked there for a long time, this is before scanning, like they just knew the item number. Milk was 1, eggs were 20, 22 or something. And they literally would, in their heads, have cataloged thousands of items, even like the Christmas trees, that every year Christmas trees, they would know that number by heart. But do you guys have that where you're like, oh, that's this part of the universe? And do you know all of these things? Like, does it just get mashed into your head?
To some degree. If you took me, if I went outside at night, it'd be pretty hard for me to point and say, oh, that's, this part of the sky, because I only know a handful of constellations, for example, by heart. I'd have to break out my phone app and say, okay, what am I looking at? But in terms of like, for instance, where Kepler pointed, Kepler looked at one part of the sky for 4 years, and I know that was in the region towards the Cygnus constellation. So like things like that, get drilled into our heads. And but Tess is looking all over the sky, so it's literally looking everywhere. And I mean, so you can pick any part, go out at night and you can say, oh, Tess probably looked there. So at least there's that.
Yeah, that's fascinating. When you are working on Tess, or you're working on Webb when it goes up in the air, how is that project based also? Like today, we're going to examine the planet. Like, how does that parsed out? Because there's so much data. It just blows me away.
Yeah, Tess. I mean, Tess is, we're getting data every 30 days essentially, and it's like a huge data dump. And then you have hundreds or tens of hundreds of new planet candidates all of a sudden to sift through every month. So it's quite a lot. With the James Webb Space Telescope, it'll be operating very much like the Hubble Space Telescope, So basically it has, it's not like a survey or anything. It's just
Mhm.
the different people propose what to observe, and it'll look at any object in the sky, that it can, but it's up to astronomers really, and some people who work on the Webb telescope. Um, they have programs to observe certain objects. So really, what Webb is just going to like shoot all over the sky and change its orientation all the time. I'm going to look at this exoplanet. I'm going to look at this star, this galaxy, whatever, and then data for that just comes down kind of constantly. In
Huh.
between. Unlike Tess, it's very specific data downlinks,
Yeah.
and then data dumps like every month. Um, so it's very different mode of operation, but still a lot of data in general from both.
Yeah, it seems like you
Mhm.
guys will at some point here in the near future have just like a live streaming ability to, task and then receive instantly. Like that seems like that's coming.
Yeah, with the Hubble Space Telescope right now, I mean, you can get it'll observe some star, let's say, and then that next day the data is in the archive for you to download. I
Wow.
mean, it's really quick, and the similar will be there'll be similar actions for James Webb Space Telescope.
Hey, so just in general for that next 12-year-old girl or boy sitting in a classroom somewhere, how do they get to be you? Like what does that look like? Do you have to go to a top tier school? Can you just go to, like at Chico, our planetarium, they didn't even have enough lights. They'd have to like here's the sun. Remember the track of the sun, and they plug it into like here's. So I mean, what does it look like to become someone who examines stars and planets for NASA?
Well, I mean, yeah, my path was I grew up in New Jersey, a Jersey girl through and through. And I went to a relatively small liberal arts school there, the College of New Jersey. It used
Uh-huh.
to be Trenton State College, um, which they're really known for putting out educators and teachers. But I was in the physics program there,
Mm.
and I was one of the few who wasn't in the teaching track. And so, a handful of us graduated my year, and we got degrees in physics, bachelor's degrees, and then we went to grad school from there. I mean, I applied to a bunch of grad schools. Um, I got into like 3 out of 20, maybe. So
Right.
there's some certain odds there you have to play a numbers game. And then I picked one. I went to the University of Florida for grad school, who had an astronomy department. Well, they still have one, but it was doing basically a little bit of everything
Hmm.
because, I knew I wanted to study astronomy, but I didn't know exactly what I wanted to do. And it wasn't until I got there that a new faculty member was there studying exoplanets, and Kepler was about to launch. And I was like, oh my God, this is exciting. So
Yeah.
I got pulled into that. And, I did the whole grad school thing, which involves getting a PhD. But a lot of people are taking different paths now. I mean, that's my path,
Right.
but a lot of people are taking breaks between college and grad school. And we have at NASA, we have so many internship opportunities actually.
Hmm.
And we have a lot of these undergrads who've gotten a college degree, and then they come to do research for a year at NASA or for 6 months before
Yeah.
going to grad school, and they just gain experience. So it's really different now, almost even than what I did. And, I mean, I didn't graduate that long ago,
Yeah.
but the times have still changed.
Right.
Um, and, then it was, for me, it was a couple more years of research that I did after grad school that kind of led me down the path of being at a meeting at the right place in the right time and talking to the right person and
Yeah.
saying I was interested in NASA, and they said, "Hey, we're hiring." And I was like, "Okay, can I
Okay.
apply?" And then that led me into NASA, and I started actually working on Kepler before the mission ended. And then I moved over to Tess and James Webb over the years. So
Remarkable.
it's
Yeah.
been, a journey,
Yeah.
certainly. And it
Yeah.
takes time, but I think if you show enough interest and passion and network, honestly, like just talk to whoever you can. That's how it worked out for me, was that networking bit really.
Yeah.
Um, pushed me through the door, I think.
Just real quick questions. Just two real fast ones. How often do you actually do math, like challenging math? Like, let me sit down with my pencil. And then, is anyone anywhere in NASA using a slide rule on a day-to-day basis?
Challenging math, maybe once or twice a month.
Okay, so for real though, yeah.
Yeah, I mean, not, nothing too crazy even. I mean, sometimes I'm just calculating the density of something,
Right.
which is like a division and an exponent. Like,
Right.
so I'm not doing like integrals all the time or,
Right.
even. So, but I know other people who do, but it's just what I do doesn't really require that.
Okay, yeah, fair enough.
Yeah, thankfully. So there's that. Slide rules, I mean, I wouldn't be surprised if
There's
somebody...
some super math nerd there,
Yeah, I've seen a lot of interesting things at NASA in the hallways, and I'm missing some of that working at home, certainly.
Yeah. Well, listen, you've been a great sport. You've answered a zillion questions, and just it's such a treat. I know everybody got a kick out. I've already received some texts and everything. So just thanks. Please come back. I love what you guys are doing. It's just so fantastic. Todd says he has a slide ruler in his office and no clue how to use it. And that's why Todd handles emergencies. He doesn't handle space. So. But just thank you so much. It's been such a great chat. I really appreciate it.
Yeah, thanks so much for having me.